My main rig right now is a gaming laptop from Asus, which has so far once overheated itself to a no boot condition. And as much as I like Asus, I don't really trust my laptop not to overheat itself again. My first solution was to just put wooden blocks to elevate it, but I would like something more. So I thought, let's put a laptop cooler. Easy and cheap, right? Actually, it was. It was actually pretty easy and relatively cheap. The first step was to actually design the thing. There are three types of laptop coolers that you'll find on the market: elevated stands, open fan and coolers, as well as enclosed fan coolers. The first two aren't actually upgrades per se, they just allow your built-in fans to work more efficiently. In fact, unless the fans on an open fan laptop cooler line up perfectly with the intakes on your laptop, they might as well be parasitic load. They do help somewhat, but they don't help efficiently enough. The only type of cooler that's been consistently proven to improve cooling performance is the enclosed fan sort of cooler. This is the type that has an almost airtight seal between the fans and the bottom of the laptop, so air coming in is almost like forced into the laptop itself. Essentially, it's putting a turbo on your laptop. These types of cooling pads do create a very noticeable improvement in performance, but for what is essentially a plastic box with a couple of fans and a rudimentary controller, they're a little pricey, which I guess goes for everything in the tech world nowadays, but it's still cheaper than, buying a whole new laptop, so it's still worth purchasing. But I like doing things the hard way, so I'm gonna try and build it myself. Material, 18mm plywood. I could have 3D printed this whole enclosure in just one piece, or I could have assembled it out of foam board since it's all just straight single plane geometry, but I just had some plywood lying around, so that's what I used. Along with my coding hammer, this also gives me one more bludgeon to use against a home intruder. Plus, I also don't need to worry about dropping it because, well, it's made of 18mm plywood. It's really strong, so win-win. I also use scrap PVC plate for the fan plate, an aluminum vent cover for the intake, and EVA foam for the ceiling foam. EVA was not the optimal choice of foam, but it was what I had lying around, so Feature Me can deal with that optimization. I sketched the design in CAD, basically a cheese wedge with the relevant dimensions at an angle which I find comfortable for typing, with a hole in its butt for intake and a hole in its face for the exhaust. Sounds backwards, but it works. At first, I just wanted to mount the fans directly to the butt plate and pressurize the entire enclosure, and have two separate chambers called the butt cheeks holding the air filters. But then I realized it's just a lot easier to mount the fans directly underneath the laptop and just use the little gap as the pressure chamber instead. This allowed me to move the air filters from a separate chamber directly onto the butt plate itself, and it also allowed me to stuff in larger 12 centimeter PC fans instead of the 8 centimeter fans that I was planning on, which I thought would give me better efficiency, more airflow for the power, but I haven't run tests to do that, but that's what I've been told, so I'm just gonna run with it. I bought two secondhand 12 centimeter PC fans from Delta. I thought 1.7 amperes was like the starting current, like maybe that's the amount of current that it takes to get from 0 to 100 in one shot, but turns out, no, that's just how much it takes when it's operating at max power, and it's always on max power because it turns out the one I got was not DC voltage controlled, it was PWM controlled. And it turns out it spins at 4,000 RPM because it's not exactly a PC fan, it was a server fan. And after burning a few jumper cables doing test runs, I realized that, okay, I need some sort of control mechanism here. Fortunately, the fans I had PWM speed control, so I could program a microcontroller to control the fan speed, which would open up a IoT possibilities like having the PC control the fan wirelessly and all that stuff. But I didn't feel like messing with microcontrollers at the moment, so I had a PWM voltage regulator lying around, so I just used that and used DC voltage control to control the fans. It is probably not the most efficient thing to do. It's probably more efficient to use a microcontroller, but it works, so Future Me can deal with it. I also bought a 12-volt 5 amp power supply along with a bunch of M4 nuts and bolts and washers, and that's basically my shopping list. Fabricating was like building any sort of plywood furniture. It's pretty easy, but just a bit tiring. I just copied the measurements from CAD to the leftover plywood, cut a little bit oversized using the jankiest but somehow most reliable tool extension I own, sand it down and get it dimensionally accurate enough to pass QC. Originally, I wanted to screw everything together so that way I can disassemble it at any time I want. But then I realized that the only part that actually needs to come off to access the internals was the faceplate. So I just tacked everything down with nails and saved the screws and all the trouble of making pilot holes for the faceplate itself. I think I used too many nails, but QC greenlit it, so good enough. I used a drill and a jank saw to cut out the output hole and used masking tape to hold the face down to drill the pilot holes for the faceplate. Always use pilot holes when working with plywood. I learned that the hard way. For the fan mounts, I just put the fans directly on the PVC plate and traced out the bolt holes as well as using a compass to draw a 12 centimeter in diameter hole and then cut it out all using a hole saw. It wasn't great, it wasn't perfect, but I could always go back and cut it up a little bit. I tried to retire for a night, but then I realized my dumb butt forgot to put a hole for the PWM regulator knob to go through. So I had to take it back outside and cut out that hole using a drill and some files. Cut out a suitable piece of plastic for a cover plate, make a hole for a knob, then glue and screw it all in place. The next day, I was pretty tired of a lot of things, so to cheer myself up, I decided to bolt everything together, wire it up, and spin up the fans. I used rubber glue or shoe cement to attach the fan and knob plates, screwed them down too for good measure. The fan plate may have more screws than necessary, but I was having fun installing them, so I hot glued the seams so the fans don't try to suck dirty air through the gaps. I cut out foam gaskets for the faceplate and for the laptop. While packaging everything, I wanted to use a 12-volt switching power supply that I had lying around to power the fans. It would improve efficiency a slight bit and would absolutely make it more robust, but I couldn't make it fit, so I decided to stick with the 12-volt power adapter instead. Fans were mounted using M4 bolts and were wired to the regulator using some spare audio cables I had lying around. I just shoved the cables into the sockets and that worked for a test run, but it disconnected randomly, so I just cut the cables and spliced them together. Problem solved. While doing this, I found out I can take the fans out without removing the faceplate, which is nice, and it was done. It was running. It was loud. But more importantly, telling by the air escaping the touchpad, it was working as intended and ready for a test run. The heaviest load on this rig is probably video editing, especially when I'm running algorithmic tools, so that's what I use for the benchmark testing. I loaded up a project, set upscale to 2 times with max enhancements, and hit render. Set the fans to max, and it randomly turns off. Oh no, what the hell? The laptop cooler shut itself down. Did it overheat? Okay. Set it into half power, run for 5 minutes, and observe. Alright. It's been running for like 5 minutes now. Here's what it looks like. Just gonna take a quick screenshot of this for later comparison. Because now we're just gonna shut it down. Leave it for another 5 minutes. See what that looks like. Okay, it's been running for a little over 10 minutes now. See the clock on the GPU when the cooler is off is just all over the place. And at times, while they're stable, they're sitting at what? How much is this? Around 82 to 85, 86. Yeah, 82 to 86. And I believe that is because the GPU just that's its safe operating limit. So it's sitting around there. Results. The laptop's service tip was still uncomfortably warm. But comparing the grabs with and without the fans, it's clear the average temp dropped significantly, and there was a drastic decrease in GPU throttling. I also noticed the video rendering faster than last time, though interestingly, the estimated render time doesn't change. Probably a quirk with DaVinci or my settings. And the laptop was certainly running way smoother. Beforehand, trying to open Chrome while rendering was basically an instant freeze, but now it was running just fine. I think DaVinci Resolve might be holding back on how much processing power it uses. I might get a better picture of actual performance if I download an actual standard benchmarking tool, but it was still significantly faster and cooler for my use case, so I considered it mission accomplished, with some concessions, but we'll get to that. There were a few problems here and there. I mean, for one, it really needs optimization. Air was leaking through the bottom of the laptop. I think EVA is just a too dense a foam to use for air sealing. I think a lower density foam would absolutely improve efficiency there. Secondly, I can't actually use the fans at maximum power without them just shutting off randomly.
What the hell?
I think this is some sort of protection feature on the power adapter, and it's one of the reasons why mid-project I wanted to switch to the switching power supply instead. I can easily fix this by using a lower profile switching power supply, but I don't have that lying around, so I'm gonna get it some other time in the future. Here's the bill of materials. This whole project actually cost 520,000 rupiah, excluding labor and tooling, but I already had a lot of stuff lying around, so taking into account delivery fees and discounts, I actually only spent 220,000 on this laptop cooler. That is half of what I would have spent for an off-the-shelf solution for a laptop cooling pad of the same type. So overall, I consider this project a success to me. And I really hope that I've encouraged you guys to find your own solutions for your tech needs, and I'll see you later.